And then Aaron's here, and Aaron just put a team together too. So I'm going to talk to him a little bit about that. Hey, buddy, how are you?
Good.
All right, James, thank you.
Good job, James.
Yeah, I mean, that whole idea about building teams from interns, that's fascinating.
I can resonate with both your guys' sentiments. I mean, it wasn't in the United Health Group. We didn't really have like interns per se. We had summer. We have some. They had a summer. I still say we. I've been there for 6 months. We had this thing called TDP, which is the Technology Development Program. Kids fresh out of college, great skills, willing to learn, willing to work hard, and all three digital transformations that I was a part of at United were all they played a key role. Right. They didn't know what they didn't know.
For those of you that don't know Aaron Rinehart, you can meet us in person in Singapore this summer, right, Aaron?
That's right. And I'm going to go swimming.
Yeah, we're at the RSA conference doing DevSecOps days in Singapore on July 15. So that's going to be a fun one. What are you talking about for us today? What are you covering?
I'm going to cover. I call it the DevOps table stakes. It's really, the minimum amount to play the game, and that's kind of my thinking here. Is that there's just some basics when it comes to software security, and the great work you all do over there at Sonatype is a core component of that. In that, and we'll get into in the slides, but there are really five key areas I want to just sort of emphasize and focus on.
You and I ran into this. We were with you, me, and Casey at the Chaos Engineering Summit in New York.
That's right.
And the reason this came about is you came to me and said, you know what? Sonatype and Nexus is just table stakes if you want to play the game.
That's right. Well, that's right. I mean, they're just some, and to be honest, when you cover the basics, it creates a level of confidence that, if bad things happen, if you assemble your software with some nasty components, that you're going to catch them, right? They're going to get caught, that, you're covered. And, that's the way you combat uncertainty is through confidence. But with that confidence allows you to, drive a higher level of velocity because those things are kind of covered. And that's what table stakes is all about.
Great. Let's get your slides up there.
Oh, yeah. Let's do that. All right. Share. Can you see the slides?
I see the slides. I'm going to go into the background, but I'll be here if you need help.
All right. Thanks, Mark. All right. My talk today is about DevOps. The DevOps table stakes is what I like to call my top 5 biggest pain points when it comes to software security. I'll give you a little bit about my background. Let's see here. I work for a company called Barricon. My co-founder is Casey Rosenthal. He created Chaos Engineering at Netflix. I am also known as being the creator of Security Chaos Engineering. This is kind of what we do. You can probably figure out what we do through that. A little bit about me. I'm generally a pain in the ass. Can I say ass? Okay, I'm just kidding. A little bit about me. I'm CTO of a stealthy startup. You may or may not already know the name now. But I'm the former chief security architect of United Health Group. My responsibility was the engineering strategy for security for the company. While there, I led several digital transformations. I'd like to give a shout out to Magnus Hedemark and Odie Ruth. They were key players in both of those transformations. Well, all three. But yeah, so I was part of leading DevOps transformation. I'll talk a little bit about that experience in this talk. We also pioneered open source for United in releasing a tool called Chaos Slinger. Chaos Slinger was the first application of chaos engineering to security. You can check it out on GitHub, Chaos, and then ChaosLingr. I'll share a little bit about chaos engineering today, but there's plenty of talks on the internet and articles I've written about that stuff. Oh, and there's an O'Reilly book that's coming in the fall. My background, it's not actually surprising that I ended up in chaos engineering and resilience engineering. I worked for the organization at NASA created Post Challenger. So a lot of folks don't know that about me. It's kind of weird how your life ends up in a certain situations. But I am I spend a lot of time in government and private sector. But I'm a frequent speaker and author on chaos engineering and security. That's kind of me. That's the Netflix team down there. My co-founder is on the very left of that Netflix picture, Casey Rosenthal. So in this session, I'm going to cover a lot of things. A lot of things I won't cover in full depth, but maybe more just food for thought. If I could achieve anything, if you're watching this talk, is help you to think differently and maybe guide your thinking and strategy around your DevSecOps, your DevOps, and your transformation. The table stakes, the things you got to cover, or you get yourself into trouble at some point. So I want to talk a bit about systems, the evolution of system design. And I want to cover this briefly because it's important to understand. So if you've never seen these diagrams, they're known as the Death Star diagrams, and that each dot on each one of these graphs here is a microservice. We are the point I want to architect here is that our systems and how we build them, we reach such a state where our systems have evolved beyond our human ability to simplify or to abstract or mentally model their behavior. When you have thousands of microservices that facilitate an app, it's very difficult to ascertain what's going on. Is it working as supposed to? Is my security as effective as I think it is? And so this used to be just the realm of your bang, like your Google, Facebook, Apple, Alphabet, Netflix. But what's happening is actually this is turning into everyone. We are now building systems. If you think about it, with continuous delivery, public cloud computing, and microservice architectures, we're now developing systems that are such a scale. It's changed so often, and are very disparate in how they interact with each other. The sheer complexity of the model is making it very difficult for us to know what's going on. So even furthermore, it's very important that if from the get-go, if you don't cover your bases or what I call the table stakes, quickly things will get out of hand. So here's a simple, just a snapshot of a piece of software called Visceral from Netflix. I just want to briefly illustrate the sheer complexity in the model operationally that we deal with. I'll talk more about this in a minute when I cover software security, visibility, and observability. Where is the complexity? What is the complexity in modern development? Okay, modern software engineering. Well, all these things you see in front of you, from service meshes to cloud computing to circuit breaker patterns, auto canaries, DevOps, DevSecOps. These are all directly related to value quicker to market, building things the right way. Building things, better team models. But it all equates to really better value and quicker value to market to our customers. Well, things like blue-green deployments, auto canaries, circuit breaker patterns, these kind of things they're very complex. They make the development environments very complex. So imagine a microservice environment. Let's say just a normal app. Let's say you have let's say a healthcare app, for example. You'll have several different microservices. Let's say you have 10 microservices. Well, you have a billing one, a reporting one, claims, payments, what have you, right? You got 10 of them. We don't really just have 10. Really, you have 5 to 6 minimum of each. So that's already 50 to 60, right? On top of that, you probably have old versions you're supporting for other microservice functionality. So you may have a couple other older versions of the existing microservice. On top of that, you may be rolling out new functionality to different parts of your user base through blue-green deployments. So magnify that. So you could just out the gate, you could end up having 300 to 400 microservices just to facilitate one app. But over time, the complexity and the nature of the model continues to change. don't forget that typically how the team model works when it comes to microservice architectures is you typically have one team per microservice. Maybe one team covers 2 microservices potentially. Each team is now delivering it maybe 10 times a day. Even if they're doing it 10 times a week, it becomes very difficult for other teams to mentally model how other microservices and teams are operating and delivering new features, functionality, and value. You could be doing all your perfect stuff from CI and CD, and problems are still going to happen. And we'll talk a bit about how chaos engineering helps you sort of get there. But it's important to note that taking care of these table stakes I'm about ready to talk about here kind of gets you to where you can do sort of more modern techniques like chaos engineering. Let's talk a bit about security. So security is still mostly monolithic. A lot of our security systems, a lot of the talks today out there are talking about DevOps, DevSecOps. DevSecOps is still not as widely adopted as it should be. It will take all of us to change the industry and how we think and how we work. But our predominantly security solution is still mostly expert. It required domain knowledge. And what I mean by that is it's very difficult for just anyone to pick up a Palo Alto firewall and understand it. Right? You have to kind of know what panorama is. You have to have had some sort of specialized knowledge, so that's what I mean by expert. It requires domain knowledge. But our tools are still mostly monolithic, and they're still predominantly stateful in a stateless world, and that's important to recognize. So let's talk about what I call the number one table stake. So number one table stake would be your software supply chain. It's important to realize and recognize that modern software is not entirely like it used to be. It's not written. It's assembled, and you have to be careful of the pieces that you put in your software. And at a minimum, understand what is there. And the Sonatype folks have some great products that really help you out there. This is very important to recognize, because I think it's one of the most what I phrased it as last time I talked to you, Mark, but it's one of the most unrecognized biggest issues in modern software development is that people don't know they're putting all kinds of potential poison into their software. They're inheriting it. They might not even know it. And it's important to not only recognize that from a security perspective, there's legal repercussions because of some of the licensing you may be inheriting if you're turning around and selling that software. There's a wide variety of different licenses that can get you in trouble. Things like the beer license, right? I know it sounds funny that there's a beer license in open source, but the beer license basically assumes that at some point somebody will receive compensation, meaning buy me a beer, buddy, right? Well, that assumes you're going to buy that person a beer at some point. It's compensation. I think here up front will allow you to at least catch it when and be aware of it and be able to make conscious, transparent decisions around it. Number 2, secrets management. This is also a very dangerous table stake that it's very important to. I cannot tell you how many times I've seen projects where a lot of software engineering teams will, because there was no secrets management solution to use, that they stored secrets and passwords and things like that and tokens, stored them in text files and open clear text. And there are better ways to do it. HashiCorp's Vault is a great product. It's one of the first and best, in my opinion, solutions designed specifically around secrets management. If you don't believe me around secrets management, what I would do is go to github.com, sign in. You have to sign in to search code. Go to the search function, type in your company's domain name.com, just the main domain.com, and then space, and then password, passwd, or secret, or key, and you'll find all kinds of interesting things. Hopefully you don't find anything. But unfortunately, what also happens is that sometimes people will expose code to the internet when they've never had secrets management to begin with, and the passwords and keys and tokens that to servers and applications get exposed along with it, and then you have a whole new set of problems along with you. So it's better just upfront to take care of good hygiene and by sort of providing a good solution for software engineering teams to, do that safely. And HashiCorp's Vault, like I said, is a good example. There's several others out there, but it's important when you're looking at solutions in this space to ascertain the difference between like privileged account management and secrets. And a lot of solutions out there they market it as a PAM solution, but what you want is software secrets management. It's completely different. It's not the same thing. Security integrated in CI/CD. I mean, I think we've had a lot of great talks at James Dean right before my talk was, and as well as the TD Bank folks were giving some great. We're talking about some of the great work they've done in DevOps and continuous delivery at their companies, and this was a core component as part of the. I want to put a shout out for Gauntlet. So Gauntlet was it was the first ever software was the first ever security tool in a pipeline-driven security tool in DevOps, in DevSecOps or rugged DevOps at the time. James said it was James. Although James now says DevSecOps, I'm sure DJ Schlane is very proud of that. But Gauntlet was a core component of helping us when I was at United move our security feedback left from our scanning and instrumentation engines. We used Arachne and SSLIs in Gauntlet to drive the scanning left. That way, by the time software engineering teams will get they would get feedback that if they introduce some kind of problem, they get it as early as they possibly could. By the time they actually had to do a pre-prod, we still had to do that, a pre-prod type of scan, that they were clean. They already knew what they were getting themselves into, and it drove a lot of cost savings and culture change, and eventually began the transformation around DevOps by sort of getting security out of the way and driving security as a component of the value stream, which is a very important thing, I think, for security to understand and be a part of. If you don't understand where you sit in your company's value chain, you need to reevaluate your role and what you're doing. It's important to recognize that automation is important, but do not be distracted by it. Simplification or I guess standardization. I mean that more than I mean simplification. Simplifying things is really in software. It's important to understand where complexity comes from. Complexity breaks down into two different types of complexity when it comes to software. You have essential complexity, which comes to things from like Conway's Law, which states that organizations are destined to design systems that reflect the way they communicate. Well, what that means is that often your software reflects the way your business operates. So without fundamentally changing the way the business operates, it's hard to combat that complexity. But that complexity is also in the way the business operates is also reflected in the value in its products and services that its customers want to buy. So it's important to recognize that the complexity also translates into value. Furthermore, there's a paper out there called The Ironies of Automation. If you have never read it, it's only 4 pages long. It was written by a woman software engineer 35 years ago. It talks about there are several ironies of automation. I call it sort of the taxes when it comes to automation. It's important to understand that there are certain things other table stakes when it comes to automation. I highly recommend that everyone read it. It should be another table stake when it comes to software engineering. Base failure is a friend. Failure is a very core component of not only the systems we build, but who we are as humans. Failure is a feedback loop into how we can improve and how we learn. Building blame culture. There's really a great. If you haven't read the Google SRE book on blameless culture, or John Paul Reed's post on blameless postmortems, it's really important to understand what blame culture means, especially when it comes to security folks in software engineering. Is that it's important to build a blameless culture, and read more about that in Google's SRE book. Systems of observability and software security logging. Okay, what I mean by this here in particular is that this would be, I would say, this would be another one of the this one's really sort of left somewhat unsolved. I need, and I have a desire to be wrong here. But in my travels throughout Silicon Valley, throughout the Fortune 50, and elsewhere, we lack as an industry good software security logs. If you think about it, how do you know what you know about when a system fails? Well, all you ever see is footsteps in the sand, right? You never actually see a line of code execute. What I mean by that is that you log events are one of the ways we see. Those are footsteps in the sand, as well as things like tracing, like stack traces. But it's important to understand, though, who writes these things, who writes these log events, right? Software engineers do. What do software engineers prioritize? Features, functions, right? And it's very difficult to ascertain, to write software security logging from, Java 7 to Java 8 over and compare a login failure with Java 7 and Node.js, for example. There are frameworks within code bases, but they differ and they drift amongst different versions of code bases. And across code bases, there lack standards and formality. We had great logging when everything was just a appliance and a known server from a vendor. But a software, you have three layers of logic you have to write when it comes to logging: the web tier, the data tier, and the business tier. And it just becomes very challenging to address this problem. So we have to really rely on instrumentation, things like scanning, things like chaos engineering, to help us understand and how our systems are behaving. Especially, so if you don't understand how your system behaves to begin with, how do you possibly expect your security to be any different? So it's very important that you have an ability to ask your system questions and get answers that make sense. And that's what observability sort of, and I'm gonna, a lot of folks will, when we talk about observability, they can, they're like, so you mean monitor, you mean logging? No, that's not what I mean entirely. Observability is also part of it is our human ability to understand lots of inputs from computers. If I made of it. But instead of having 40 different microservices listed on a spreadsheet or a table, say microservice A1, A2, A3, what have you, it's easy to say, it's red. Oh, that must be bad, right? Or that's yellow. Or like it's very, we can mentally model this creates something that we humans can process versus lines and lines of information that very, very difficult for us to hold in our heads and model and shape our thoughts around. So moving on to continuous security verification. This is where the security chaos engineering stuff comes in, is you could be doing everything right and perfect from a CI/CD perspective, but because I described earlier in our 10 microservice model is the sheer size. I mean, it doesn't even have to be microservices to have this problem. Is that you have to think about it. Is your system, you have this idea of a system from the very beginning. You got to, as the chief security architect at United, I always worried about Ivy Tower syndrome, right? Where I would be providing guidance and recommendations, controls, and capabilities around things I wasn't sure were actually effective or not, And, one of the things that I recognize is that when a system is designed, when it's put on paper, that's just a mental model of an understanding of some engineer, some architect, how they perceive the world, right? Well, there are many different roles when it comes to building software, and people have different perspectives and mental models. Furthermore, when security controls capabilities actually get built and engineered and configured, the devil's in the details on where the problems reside. And you never really know how effective things are. So one of the things that I was able to do with Chaos Slinger was provide an element of continuous confidence in whether or not those controls or capabilities actually worked. And what we did is with Chaos Slinger, we introduced the expectations by which we expected the security mechanisms to work, right? So if we the other alternative, and this is the state of the world, is we wait for something bad to happen. And we also assume the fact that we had enough information to ascertain what actually happened. A lot of times we'll come up with things like root causes. Well, root cause has never really ever been a thing. It's always usually multiple things. But if you come up, so the root cause, the reason why it's not a thing is the same reason why you can't ascertain why a root cause for why, let's say, your career or your company is successful. You can't name one single thing. Is the same reason why you can't name one single thing why something goes bad, or why it's not, or it's in the reverse of something positive, where it's negative. Oh, go ahead.
I was going to say, I'm just giving you a 4-minute heads up.
Yeah. Sure. Okay, well, I'll briefly cover chaos engineering. Okay, so by taking care of the table stakes, it allows you sort of to go on to more advanced understandings and behavioral understandings of your system. And so chaos engineering is one of those. So chaos engineering is the discipline of experimentation on a distributed system in order to build confidence in a system's ability to withstand turbulent conditions. So it's the confidence piece here in chaos engineering that I wanted to bring forth when it comes to the table stakes, is by taking care of those 5 table stakes, you're able to be confident that when, let's say, for example, when somebody misconfigures a firewall rule or something, or they have an unauthorized port change, the same sort of thing, and just the cause is different. But is that when that kind of thing happens, you're confident that you're going to catch that your controls work. Or when you inherit a bad package or a binary from another piece of software that you want to use, that you understand what else was in there, what else other things that might have introduced other problems in your software. That's where Nexus is really, instead of the Sonatype folks really got that covered. So it's about building with confidence what actually works. That way you can drive velocity and innovation and value for your customers. So it all comes down to, I love what John Osbaugh says, it's time to stop looking for better answers. It's time to start asking better questions. And that's what this is all about. So I think I have a few minutes to finish this out here. But it's about asking yourself, what is the system actually doing? Has it done this before? Why is it behaving that way? What is it supposed to do next? And how did it get into this state? So that's what this is all in reference to chaos engineering and continuous security validation. But what we're trying to achieve is an accurate mental model of how our system and our security really works versus how it works in reality. And like I said before, like taking care of the table stakes, you're able to look at a broader lens and look deeper at how your system actually functions versus how you think it does. And furthermore, you're able to provide actual objective evidence that either works or it doesn't. And if you failed, remember, failure is our friend. Failure is important. Failure is what we need to create better humans and better machines. So that's it.
So that's it.
That's it. That's all you need. That's all you need right there.
There you go. Thanks.
Mark, thanks for having me.
Hold on just a second here. Alan, jump in here. Just say hi, Alan. I think you and Aaron should know each other.
Hi, this is Alan Friedman. How are you?
Howdy. How you doing?
I'm doing all right.
Yeah.
Been fun to actually hear from some of the folks that are doing real engineering today. Not something I do much these days.
Oh, I agree.
All right, Aaron, they're waiting for you over in the Slack channel, and they're going to say thank you, and I'll say thank you, and I'll see you in Singapore on the 15th, if not before.
Looking forward to it.
All right, great.
Good one.